I'm down here because I want to talk about that. Yeah, got another piece of interesting science news that I thought I'd share. There's other stuff. I think some of the other stuff I've covered might be more interesting, but this is still pretty neat because it's a very unexpected discovery. But I will admit I don't like this. I don't like this headline that they're really using it mainly for missing link. Just when we get into that, it'll make more sense. But it does concern this unusual galaxy. And the summary here I'm gonna just go right by because it kind of spoils it, and I don't necessarily like how it's spoiling. Here, let's see if this will work. Well, yes, okay, perfect. So for our full article here, and of course the link is in the description, and it's from the James Webb Space Telescope website. So the idea here is that the Webb telescope is going around looking at the universe, collecting data that's not just images like we see over here, but is also collecting spectra because certain things give off light at certain frequencies. Now, some that we can play with, for example, LEDs. How do you get red color? How do you get green color, blue, etc.? It's because there's materials in there that only emit that certain color of light. And also like a neon lights operate on the same idea, where neon, I believe it actually glows, it's an orange color. There are also gases that'll produce a like green color. If I remember correctly, helium is kind of like a very, very bright purple, bright enough that if you look at it, it looks mostly white, but along the edges you may see some purple. It's been a while since I've looked at helium light. So when you would look then at an ancient galaxy, this one, approximately 1 billion years after the Big Bang, which, shouldn't that be capitalized? I mean, that is a proper noun, isn't it? Because you're referring to one specific event in time. It is a noun. Pretty sure it's a proper noun, but anyway. So it's definitely an ancient galaxy, and they were looking at it. And it's like, that thing's really bright, and let's look at the spectra. That doesn't make any sense. Because they were seeing spectra there, so frequencies of light that don't make sense for a bunch of what are called population 3 stars, talked about down here. Because Big Bang Theory, shortly after that, the majority of mass in the universe would have been hydrogen, helium, and a little bit of lithium. A little bit there. Population 3 stars would be basically just big old balls of hydrogen and helium with a nuclear fusion core. And galaxies would be collections of those, along with a whole bunch of the gas just hanging out, at least until those stars go supernova and such, and then produce heavier elements that are distributed everywhere. Okay? So what's weird about this is they were seeing spectra that don't align with population 3 stars. Like they're seeing, it actually even references here that there's more complex chemistry being shown to us in the data than what we would predict for these. So it's definitely confusing. And for that reason, this Alex Cameron of University of Oxford reached out to colleague Harley Katz, a theorist, to go over the data. And what they end up doing is taking computer models for galaxies and such, because those do exist, and decided to start tweaking the numbers. And what they found explains the data, and I think it even says like almost perfectly. Was a nearly perfect match to the observations, is what if the light is mainly coming from the gas of the galaxy, instead of the stars. So it's like you look at a lot of galaxies and the majority of what you'll see there is gas and dust. It shouldn't be too much dust necessarily this early on, but certainly a lot of gas. That's shining brighter than the stars itself. That's what that's what they got the model to do. And that matched almost exactly their data. So I was like, oh, looks like that's what's happening here. Which is definitely a curious thing. And could potentially be a missing link. I hate that term. I will explain that in a moment. For this situation, I hate that term. Potentially a missing link in galaxy development. But there's more to this. First, though, I want to explain why I don't like the term missing link for this. We didn't know it was missing. I understand if it's okay, we've got A here, we've got C here, we need the missing link of B. But this, from what I was seeing here, there was nothing to suggest we would ever encounter something like this. Or at least in this context. Well, no, just like this. Because the idea of having, it does mention, mentions in one of these, I think it's one of these two paragraphs, that basically finding a galaxy that would have its gas hotter and brighter than the stars. Yeah, we can kind of see that happening with population 3 stars, which are these first generation stars, just hydrogen here. Okay. But here's where it gets really weird. We know that the galaxy does not have population 3 stars because there's too much chemistry going on there. This isn't a missing link. This is a, what the hell is this? And is definitely a very, very interesting scenario to find, especially because this is still a very ancient galaxy. Now, I think I'd have to check. I want to say that some observations, or at least some models, some theories, put initial galaxy formation much earlier than this, like around 300 million years, 400 million years after the Big Bang. So we're talking 600 to 700 million years before this. So it's definitely, there's potential for chemistry to exist at this point, more than hydrogen and helium, but it's still, we're not expecting stars to be so massive and so bright at this period in time. We don't expect the characteristics of population 3 stars in non-population 3 stars in a galaxy. And it's like that, we have no idea why. So it's like, yeah, that's a weird thing, but that's not a missing link. We don't know what the hell's going on here. But it is also, as is pointed out here, we don't know what this means. It might mean almost nothing. It might be that this is a single example in the universe. And it's just instead of things developing like this galaxy decided to go dink over here. Don't know. We will have to find out, because it is also, I mean, yes, the Webb telescope was designed for many things, but part of its purpose is specifically to look at such ancient galaxies and other stellar, intergalactic objects. That is part of what it was designed for. So we are going to end up, it's like, as the closing quote here does point out, we're going to end up finding a whole bunch of things that might not fit theories, might run contrary to theories even, or that might be just weird one-offs that we don't know why, might never really figure out why. So, yeah, but I did think that this was interesting, wanted to share it, and also I just like you do have to consider generations of stars at times, because it's like that's how you get the various elements that we find on the periodic table. It's like how, because we have up to uranium, it's one of those weird things when I did that other nucleosynthesis video, how, looking at that, technically plutonium can also be made naturally, but I'm pretty sure from what I was seeing, it's like, no, that dies out, that decays so quickly, we don't count it. Uranium is the only thing that is the heaviest element that can be produced naturally that would stick around to be observed. But to make that, you need, I'm trying to remember. I remember part of it. It's the S reaction, I want to say, but it would take either a really, really big star to explode, really, really, really massive supernova, or neutron stars colliding. Okay, which neutron stars means that you also already have at least 2 stars that grew old, went supernova, and collapsed down to neutron stars, and I don't think population 3 stars are expected to be able to do that. I could be wrong. It's just I have a feeling that does start involving chemistries and such, and scales that are different than what population 3 stars would exist on. So yeah, we're going to be finding all kinds of neat stuff. But yeah, so definitely, the link is in the description, so you can go and look at that. I do wish that this were a little better written, because it's weird to, I was like, you're spoiling right away, with its gas shining brighter than stars. I was like, come on. I get it's a summary, but, build up that there's something weird going on here. Yeah, and also that's, may represent a previously unknown phase in galactic evolution. It's like, yeah, so it's not a missing link if we didn't know it. Missing link, you're expecting, it's like we need something to fill in there. Anyway. See you next time.